Alrighty, here we go. Let's get cruising. So looking at this cube root here, we're doing a cube root of this humongo gross fraction. We're going to start by cutting it into pieces. I'm going to split it into be cube roots, numerator and denominator. That'll make things a little bit easier to deal with. And I'm going to come over here. So we're going to do our cube root of 27 x to the 7th, y to the 9th, and the cube root of 8. So first step is to split it into numerator and denominator. Then I'm going to come over here and I'm going to split the numerator apart into different products. Since those pieces are all multiplied together, I can split them up individually to be the cube root of 27, the cube root of x to the 7th, and the cube root of y to the 9th over the cube root of 8. And then we're going to simplify each chunk individually. So let's start with this one here. What is the cube root of 27? 3, because 3 cubed is 27. So that purple thing just turns into a 3. And you can also do that one by typing it into your calculator. I'm going to write the next one down. Our cube root of x to the 7th. What are we going to get here? Yeah, we can take out 2 groups. We can take this into the cube root of x to the 6th and the cube root of x. Because x times x to the 6th is x, which is going to give us x squared on the outside because we're dividing the 6 by our index. And we're going to have a cube root of x left over. And then how about our blue one here? Y to the 3rd. We divide the power by the index. That one divides out evenly, so we can just go right to it. Y to the 3rd. And our denominator, cube root of 8, 2. Technically, that is a correct answer. It is not the best grammar because we have things not in the square root after the square root. So all I'm going to do here is I'm going to change the order to be 3x squared y cubed cube root of x over 2. All I did was take this y to be in front of the radical because our best grammar has all of our letters and numbers that are not in the radical in front. So break it into tiny pieces. We divide the power by the index. And that is honestly how we're going to be, or what we're going to be working with today a lot. Because yesterday we took all these roots and we divided the powers by the index. Today I'm going to give you a fraction there and we're going to put it back as a root. So we're going to be dealing with something called fractional exponents today. Questions on the bell work? Okie dokie. So we're going to do fractional exponents or rational exponents. And again, the paragraph is not important, but the little picture at the bottom is. You're going to want to have that. This is what we use to simplify our strange roots, our cube roots. We did it for our square roots as well. We've done this, where we take our index and divide our power. This just shows you that it works the other direction too. So if I give you something with a fraction, we can write it as a root. So what we have is whatever our base is, it's usually an x or a y or a number. The p is our power, and the denominator, or the n, is our index. Again, I'm not super concerned with the paragraph. This side is called our radical form. Because it's got a radical in it. And this is called our exponential form because it's just exponents. I feel like even if I didn't tell you that, we could kind of intuit that, but I'll tell it to you anyway. Got our exponential form and our radical form. And that's how we're going to start, is just switching between the two forms. We're going to take things that look like this and write them as radicals. We're going to take radicals and write them as exponentials. Okay. I was waiting for the pen to go down. So here's our first two. We're going to write x to the 4/3 in radical form. So I even gave us our little rule up here. X to the pn. That means that this is my power and this is my index. So what we have is our base, which is still an x, has a power of 4, and when we put it into a radical, it has an index of 3. So x to the 4/3 is the exact same thing as the cube root of x to the 4th. They are identically the same thing. Whatever the numerator on our power is the power inside the radical. And whatever the denominator is our index. It works the other direction too. So on the bottom one, we're asked to write the 5th root of x squared. Well, we've got an index of what? What's our index? 5. And we have a power of 2. So when we write it in exponential form, we have x to the power of 2, because our power doesn't change. Power is still the top. 2 over 5. Whatever the power is here is still going to be our numerator here. Questions on the first ones of these? Okay, because we're going to start playing with them and we're going to be switching around between both forms. Okay. So the first thing we're going to do is we're going to write these in radical form. So I didn't give us our little notation up here. We have x to the p over n equals the radical n x to the p. So what we're going to do is we're going to switch them around. So x to the 2/3 becomes what kind of root? Which one of these is the index? The 3. The denominator is our index every time. Okay, so we're going to take, and we're putting this 3 comes outside. And inside we're going to have our x squared. So what's on the top stays on the top. We really don't like fractions, so we're going to move that fraction piece outside. The right-hand side, we're doing a very similar thing. I have a power, and I have an index. So we can write this, it doesn't matter what's inside, we can start this out exactly the same way. With our cube root of 1/8 x squared. All of this has a power of 1. Does a power of 1 actually do anything? Nah. So you don't have to put it. You can if it helps you to remember that power of 1, but you don't have to put it. We could simplify this one. But we don't need to right now. Mostly this is just about the form to start with right now. All right, let's go the other direction. We're going to take rationals and put them in exponential. Take radicals and put them in exponential form. On this one, what's our index?
That's 2, right?
2. If there's nothing written there, our index is 2. Square roots won't have a number written there, but they do still have an index of 2. So when we write this into our exponential form, our base is still the same. We still have x to the power of 3 over 2. Power over index. Okay, let's set this one up. And I'm going to start doing it just like with, this is a big chunk. This one we are going to simplify a little bit. So I have the whole chunk of y to the 9th, x to the 7th, being taken to the cube root, which means to the 1/3 power. So you can write it like that, as one big chunk. We could also think about how we would simplify this, where we'd break it up into pieces. It's the same thing. It feels like we're going to distribute this power here. This is called the power of a power, and that's an Algebra 1, remembering our old exponent laws kind of dealio. where I take and I'm going to multiply powers together. So this is also going to be the same thing as y to the 9 thirds and x to the 7 thirds. Can I simplify one of these? Yeah, 9 thirds. That's the same thing as y cubed. 9 thirds equals 3. And we're just going to leave the x as kind of gross. So the benefit of switching it around to exponential form is I don't have to think that hard about what the cube root of y to the 9th is. I know that 9 thirds simplifies down to 3. It takes roots and makes them into fraction simplification. Okay. It's not always just going to be letters in there. Sometimes we're going to have numbers. And we can set them up exactly the same way. Yes, dear. Yeah, let me get your pass. Give me a second. I just want to make sure that this is open on the right screen. We can set these up exactly the same way. We still have a power, we still have an index. Here we're done. So we can write this as 8 to what power? 4. And our radical has what index? 3. So we can do it like this, and we can evaluate it like this. We can find out what 8 to the 4th is. There we go. Oh, come on. There we go. I need to be able to actually see it. We can find 8 to the 4th. That's 8 to the 4th. 4,096. Super gross. So this gives us the cube root of 4,096. And we saw yesterday we can do the cube root where I type in my index, hit the green button, and then hit my any exponent button, and that shrinks my 3 down. We have 4096. And we get 16. So this becomes 16. And that works. That is totally fine. That is an entirely doable way to do that operation. It does leave us really vulnerable to mistypes. There's an easier way. After we excuse our friends for WIDA testing.
We are continuing with WIDA testing this morning. Students in Group A, please report to your testing locations. Once again, students in Group A, please report to your testing locations.
All right, so our easy way to do this is if I take, and I want to do 8 to the 4th thirds. That's not the button I wanted. We can put in our base of 8. We can hit our any exponent button. And then we're going to hit the fraction button. And we can put in the whole gosh darn thing, 8 to the 4/3. It'll do the whole thing for us. Okay, so we need to know what's happening, but when it's just a number, you can type the whole fraction in, and it saves us a whole lot of errors in just typing things. Okay? So that's why I showed you the other way first. Snap. Okay, so you can just type the whole gosh darn thing in. So when we're looking to do our 32 to the negative 2/5, we're going to do 32 as our base. We're going to raise it to a power. So we hit the little up arrow on the left-hand side. It's a fraction. And we can even do negative. Grab the bottom one next to the enter sign, not the minus sign. In a calculator, minus and negative are not the same thing. And it was 2/5. Okay. Double checking. Yes. It even simplifies it for you. We get 1/4. So when it's just a number, the calculators can do a whole lot of stuff. So this one simplifies down to be 1/4. So you can do it the long way, remembering our exponent laws, or we can do it the easy way. Perfectly fine with either one. Okay, so when we're looking at the numbers, we're just typing them in the calculator. We know what's happening. We've been working with what's happening, but there's a shortcut. We love a shortcut. Okay, I've mentioned them a couple of times, and they're going to come up as we go through and working with these. But we are going to go through and remember some exponent laws to practice this. This is the last page for today. So pretty chill day. We'll have lots of time to work on that homework because I know we talked kind of all the way to the bell yesterday. So we will have lots of time today. So we've worked with exponent laws before. You spent a whole chapter on them in Algebra 1. And I know for some of us that has been a hot minute. And that's okay. So we're going to remember. And sometimes it helps to remember not just looking at the fractiony ones. I'm going to grab a dry erase and I have to grab a physical board. Oh my gosh, what? So when we are multiplying two exponentials together, or two exponential statements, let's say I have x squared, no, I'm not going to do squared, we're going to do cubed times x to the 5th. What do we do with those exponents? What's our answer for x cubed times x to the 5th? We add them. This becomes x to the 3 plus 5, which is x to the 8th. So when we have it in fraction exponents, it's the same thing. When we are multiplying two pieces together, we're going to add the exponents. X to the 2/3 plus 1/6. When we are multiplying the bases, we add the exponents. What is 2/3 plus 1/6? Another thing, we love the calculator. 2/3 plus 1/6. When in doubt, you can do part of it here. We love the yellow calculators. They do good with fractions. 5/6. What they did was they got these to be common denominators. So they multiplied this one by 2/2 to make 4/6 plus 1/6, giving us 5/6. So common denominator is what we're looking at here. Figure out how to draw on the calculator. So this gives us x to the 5/6. And that's where we stop on that one. That one is fully simplified. What does a negative exponent mean? What do I have? X to the -2. What does a negative exponent mean? A negative exponent is going to make it flip. It's going to go upside down. It's going to become, so on our -2, this becomes 1 over x squared. So on our fractional exponents, it does the same thing. We're doing 1, ooh, wrong pen. 1 over y to the 2/3. It puts it into the denominator. Or it's going to be 1 over, and we could switch this back into being our radical form because that looks super gross having a fraction in there, where we have y squared, and we're taking the cube root. These things all mean the same thing. These are all equivalent. And there will be times that all 3 different forms are useful. Bless you. Ew, last one's super gross. The last one kind of combines them together. It has a negative exponent, so we could write it as a denominator. It also has a product, so we could add them. And you can choose which way you go. You can either write it as a big fraction, and then we would wind up subtracting our exponents, or we can leave it as a product and add our exponents. I think it's easier with these to leave them as they are right now and to take my z to the -1/3 plus 3/4. Since we are multiplying the bases, we are adding the exponents. And again, we're going to say, I love the yellow calculator so much because we can come over here and not have to do the common denominator part ourselves. We have our -1/3, 3/4, plus the fraction 3/4. They got to a common denominator of 12, and then they added 5/12. So this is z to the 5/12. So it's gross. It's super gross. But that's what that simplifies down to. We're not often going to deal with anything this big, nor are we going to deal with a ton of operations in the exponents. But it's important for us to remember those exponent laws because they will come up every now and then. Okay? So we have 10 minutes to the end of the period, or at least 10 minutes until announcements. So you get that whole time to work on homework 3. I handed that out yesterday. we have another quiz a week from Friday. Okay? We've got this whole week and then next week, Friday, which is February. Isn't that crazy? Next Thursday is February. Weird. Yes, too. Yes, it's over in the gold folder right behind the tree. Yes, dear. Yes, let me write your pass.